So I am recording, so anything will be held against you 36 years from now when you're going to be trying to get a judgeship in the Supreme Court. He threw ice. Kavanaugh threw ice while he was in college at somebody. He cannot be on the Supreme Court. When he was in college, he threw ice at somebody in a hotel room. I think there's some politicians in D.C. that have lost their damn mind. I really do. I think they've lost their damn mind. I turned over an ice machine when I was in the Marine Corps, so I can't be on the Supreme Court. Whatever. I think they're retardicus is what I think. Y'all know Spartacus plus retardicus. You know. I can say retardicus because that's not a word. If I say the other word, then somebody will say I'm offended. So I say retardicus.
It's going to be really loud.
All right. So here's your handy dandy. Is that the question right there?
Yeah.
All right. So I'm going to take, just making sure, did I hit record? I did hit record. I'm going to take this and I'm going to highlight it and I'm going to send it over to the handy dandy chart plot. And there it is, scatter plot. And then I'm going to right click and then I'm going to hit add trend line and then I'm going to go over here and hit display and display. Okay. Now, somebody take the square root of 0.9884. Somebody tell me what that is. 9942. So let's write that down. R is equal to 0.9942. So write those numbers down and write that equation down. And let's go back to the question and let's see what they're asking. And then we'll have to go look up some of the squares, but that's not important. We'll look it up and see. 0.9942, 0.9884, and then write down y is equal to 1.9767x plus 6.6512. I'll make it a little bit bigger for y'all. There it is. And R is equal to 0.9942. So does R tell you that there is correlation? Yes. And that's the thing I'm going to ask you on the test. I may ask you the equation, and I may ask you to predict for 10 years. What would you do if I asked you to predict for 10 years? What would you do? Plug 10 into the formula, the equation for X. Yes. That's the three things that I'm going to ask you. So, oh my God, we're being invaded. The Russians. So let's go back to our handy dandy question. All right, it says compute the sum of the squares, round to 3 decimal places. Well, let's look back. Let's look back at the, no, that's not, 3 decimal places would be 0.994. So we'll have to go back in the book and look for it. I'm not gonna put a lot of emphasis on it on the test. But I tell you what, let's just do it the easy way. Let's go here and hit view an example, so we won't have to go up and look it up in the PowerPoints and everything. Because I know they're gonna give you a formula. There's the slope. Okay, find the slope, find the equation of the line. We did that on the, you can do that on the calculator too. I'm not worried about that. I'm just scatter, found the line, recall the line passes through, recall, by hand determine the least squares regression line. Y is equal to bx plus bo, where b1 is equal to r is the slope of the least squares regression line, is the y-intercept, and least squared regression, find the correlation coefficient. Well, we found the correlation coefficient. It's 0.99 blah, blah, blah. So D says first find the correlation coefficient. Oh no, we're not doing that. No, that's R right there. That's what we found. So D, put D should be R. I don't know why. Where's D on the equation? Hold on. Where's D here? So D says find the, good gosh, how many parts does this thing have?
7. That's how all of them. One of them was like.
Okay, we did this. We did A.
Yeah.
Okay, we did B. All right, we did C. D, I thought we did that too.
We did.
We did that. We did D. We did D. Hold on. Graph the least squares. Give me, okay, here it is. Okay, C. Graph the line found in part B. Oh. Okay, this is what they're doing. All right, this is what they're doing. They're pulling the first 2 points, or the first point, okay, the first point and the last point. They're telling you to find a equation of the line with the first and the last point for B. Okay, do you understand that?
Yeah.
Okay, let's just do it. Let's just do it. Okay, let's go and let's, let me put up the handy dandy. See, I didn't show you that because to me that's really worthless. But what they're trying to show you in the homework is they're trying to say how close is the line to the actual best fit line is what they're trying to show you. Okay, so what you do first, and we did cover slope and y-intercept. I just didn't do it. I just didn't do it with the problem. So they're telling you to grab these 2 points right there. Okay, B, this is, I think B, yeah. So it says find the equation of the points containing these 2 points. So I'm going to take 4, 7 and 9, 17. And then which way do we read? Left to right, Hubert. This is x of 1, this is y sub 1, this is x of 2, this is what? Y sub 2. Now find the slope of that line. Now that is the slope of the line connecting the first point with the what? The last point. This is not the best fit line. But what they're trying to show you in the homework is, okay, this is the line of best fit versus the line between the first and the last point. That's what they're trying to show you. So, slope is equal to delta y over delta x, which is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's going to be 17 minus 7 over 9 minus what? And 17 minus 7 is 10 over 5, which is 2. Now, which point am I going to pick for the point slope equation? I'm going to pick the first point. Why? Because it's simple math. So the point slope equation is y minus y sub 1 is equal to m times x minus x sub 1. And did I cover this yesterday, Monday? Did I cover the point slope equation? Okay, I thought I did. So y minus 7 is equal to 2 times x minus what? 4. Now solve that for y. You're going to have to distribute the 2 and bring the 7 over. And that should give you this right here. Check it and see. 2x minus 8 plus 7 is negative 1. Yes. Okay, so we got down to B. So A, just plot the dots. B, do the slope and the y-intercept. I mean, the slope and the point slope equation. Graph the line. Graph this line onto this point. Well, it's going to connect the first and the what? It's going to connect the first and the last dot. So this is your graph. So I'm going to put a line from here to there and ignore the other points. Well, that's the best I can do with this.
That's actually pretty good.
Thank you. All right, so you're still going to fail. All right, so that's that line. Now, is it the best fit line? No, and that's what they're trying to get you to see. So graph the line. So we did C. So let's go down and see what D says. But I don't understand what some of the stuff they're wanting you to do.
Yeah, I wouldn't like bring it up if it wasn't part of our grade.
I know.
I know that like.
I know. I didn't know they were asking all this. Okay, graph the part. We did that right here. We did that. By hand, determining the least square. Is that what we got on the Excel spreadsheet? 197. Okay, we did that. And then that's the best fit line, which is there. Okay, F and G. Let's see what F and G is on the because I've never taught the sum of the squares unless they've F and G. Let's go to F and G and see what they're doing so we can decipher what to do on the homework. Because I don't, F and G. Huh. That's why I told you not to do the formula. I'm still looking for F. If I skipped it.
No. That's E.
Good, gracious alive. Oh, the observed minus the predicted. That's what they're telling you to do. So, you got to go back and get the, oh God, that's a pain in the butt. Okay, this is your first, okay. Oh my gosh, yeah, that's a pain. Square it. The summation of y. I'm looking to see what they do.
Just see how long it takes before you explode.
That's what they're trying to do.
Oh my gosh.
Too much stuff.
That's way too much. We're not. It's got to. Somebody do it on your calculator. The calculator's got to show you that. Okay, we're gonna punch this in the calculator and find it on the calculator because I'm not gonna ask you to do that.
Get that out.
Okay, so let's punch these in. I'm pretty sure the calculator is going to give you that.
It's Wabbit what? It's not on the website. Oh, dang it.
Yeah, poor old Apple people. Sorry. I guess Apple is scared that Wabbit EMU is going to destroy their system, so they won't let y'all pull it up. Apple is a joke.
I love that. We'll probably find another.
All right, so y is equal, or we're going to go to stat, edit. Somebody give me the points for x. Did y'all write it down? No, you didn't. So let me pull it up again. Thanks y'all. I appreciate it.
I didn't have time.
Oh yeah, you've just been sitting here all morning.
What is he doing?
No, so let's all right, 4, 5. We're gonna work this out for y'all. 6, 8, 9, and I have a feeling that all that other stuff that's on there is your answers. 7, 9, 12. 7, 9, 12. Now y'all should be typing this in your calculator if you have one. 7, 9, 12, 15, 17. Unless you're one of these poor pitiful Apple people that don't have anything to use on their calculator on their phone. All right, so calculate. So we're going to go to stat, calculate, and linear regression. And calculate. Oh, great. And now you got to turn on that stupid, let me turn that on. Hold on. I guess you have to turn it on every time you turn your calculator on. Does anybody know?
Mine didn't.
Okay, well, oh yeah, with this one you do because it's on Tri-County Tech's computer system. What's wrong with the wabbit? Okay, she's lost it. All right, calculate linear regression. Calculate. All right, look and see if any of those numbers. No. All right, let's go here and let's find out what to do to find sum of squares on TI-80. Of course, y'all can do this, but a lot of work. You have to hit a button. All right, sum of squares on TI. How to calculate the sum of squares. Calculate the mean, subtract each we're not doing that. No. How do I do summation? Okay, I tell you what. We're just going to have to, I'm going to have to research it and see. There's got to be a way. No, doesn't look like it. Looks like you have to do it. I tell you what, let me just put those questions on hold for right now, and let me see what I can do. Let me see if I can research and find a way to do it on your calculator, because I do not want you to do all that math. I mean, there's nothing wrong with it. If you like whips and chains, knock yourself out, but I'm not going to ask you to do that on a test, and I'm surely not going to ask you to do it on homework. So just let me work on that, and I'll get back with you. Do the parts that you can do, the parts that I did, do that, and don't worry about the other parts, and I'll either make it up and give you the points, or I'll show you how to do it on your calculator, whichever one I find. If I don't find it on the calculator, then I'll just give you all the homework points, okay? Don't worry about the sum of the squares, all that. Don't worry about that. I'll figure it out and get back with you. Okay? Is that fair?
Yes.
All right. So let's go back. Let's get back on track. All right. And the reason I say get back on track is I want to get to probability. Okay. So we're going back to probability, chapter 5, and probability rules. Now, again, most of you have seen this before, so I'm going to be teaching mostly those people that have never seen it or sucked at probability. So we're just going to go over some things and go from there, okay? So I don't start with this. I start with something else. So let me just, I just pull this up to make sure I cover everything. Y'all all know where Wild Hog Road is, right? Okay, here's where we go. Wild Hog Road. Y'all ever heard Wild Hog Road before? Y'all never had any parties on Wild Hog Road. Okay, y'all have been deprived. All right, but don't go to parties anymore, because if you go to parties, you'll be accused of raping somebody. All right, so Wild Hog Road is what some people that aren't from around here call Highway 187. All right, there's two Highway 187s. There's one 187 that goes down to Shiloh Church, and then you hit a right and go to Hartwell, Georgia. Okay, that's Highway 187. 187 that goes to Pendleton is not Highway 187. That's called Wild Hog Road. All right, and I'm telling you this for a reason, so just bear with me, okay? All right, y'all know where the double bridges are? Okay, that's the two bridges that go over the lake. All right, okay, because I don't want, as some people call it, the twin bridges. That's the people that ain't from around here. They call it the twin bridges. All right, you cross the double bridges, and you get up here. There's a store up here, and I can't draw with this. There's a store up here and a red light. Y'all know where that is? And the dang old Portman, what's it called? The galley. That's where my daughter works. She's back in there. Okay. And then this road right here is called Wild Hog Road. And it goes all the way to Pendleton. Pendleton High School, dang old right here. Okay, that's Wild Hog Road. I'm going to spell it out for you so you will know how to spell it. Wild Hog Road.
Was this just so we knew where it was, or is there like a thing behind this?
What?
This just so we know about it?
I'm telling you a story.
Okay, I'm listening.
Can I be in charge for a while? All right, so, okay, this way is 24, and you get the I-85 up here, okay, I-85. All right, now, whenever, it's 16 minutes to get from my house to get to Pendleton, okay? 16 minutes if you go Wild Hog Road, because there's no red lights, okay? But, it's a double-edged sword, just like everything, there's two edges. There's no red lights, but if you're, let's say you have an 8 o'clock class, and you get on, you're right here at 7:45, okay? As soon as you turn on Wild Hog Road, there's this club, and this club is called the Little Blue-Haired Ladies Club, okay? And they drive 33 miles an hour.
Oh, no.
Y'all have all gotten behind these people, and you get behind them on a 2-lane road. Now, you are not that important that you need to pass them, okay? You're not that important. You're not the president or anything. You're not that important. But when you do get behind somebody like that, and on Wild Hog Road, when you get behind somebody like that, you're stuck. Why? Because you can't pass on Wild Hog Road. It's double lined all the way, pretty much. And if you try to pass, you might be on a head-on collision with somebody. Okay, because there's a lot of people coming to Anderson from Pendleton, because they don't want to go down Clemson Boulevard. Okay, so there's a lot of people coming the back way to go to work in Anderson. So you might get hit. All right, so you get all the way down here, and there's a red light, and it dead ends. Okay, dang old Waffle House in Pendleton's right here. Okay, and here's the dead end right here. Dang old QT and whatever's down here. All right. You get up here. There's 2 lanes. There's the lane that goes that way, and then there's 2 lanes right here. One turns left, and one turns what? Right.
I'll tell you though.
You get up to about 200 feet before that red light, and you say to yourself, "That person's going to turn left." Why is that person going to turn left? Because that's where I'm going. And you do that, and just as soon as you say that, about 10 seconds later, the left blinker goes on.
I don't know why, but this is literally me when I'm driving. Like,
Exactly.
I
Okay, good. That's a good thing, because
every time you see the handicap tag hanging up, you're like, dang it.
Yeah, you're screwed. Okay, because you're not going to make it, and you get to school. You get to Tri-County Pendleton campus at about 8:20. Okay, I'm serious. You do. Anyway, so I was able to tell the future, wasn't I? Because I predicted that that person was going to turn left. So I'm able to tell the future. Yes or no?
Yes.
No. Nobody. No matter what your aunt says that she can tell the future, no matter what your crazy cousin says, all you got to do, anybody that tells you they can tell the future, ask them one question. What question would you ask? Come on, people. Think. What question would you ask? The lottery numbers?
No.
I want to know the lottery numbers for Wednesday night drawing. And what will they tell you? Oh, I can't do that. Well, you can't tell the future. Okay? Then how was I able to predict the future? What did you say a while ago? This always happens to what? Me, right?
Oh.
Experience.
I don't know. I say a lot of things.
Experience. How many times has it happened to you?
A lot.
A lot. Okay? Another thing. Calculate. Now, I didn't do any calculations here, but there are applications to where you can calculate and predict. All right? And then the third thing, logic. How many of you, and I'm just going to ask for somebody, the persons that live in this area called West Anderson know what I'm talking about here, logic. All right? If you live in West Anderson, anywhere from, I would say, the airport, dang old airport's right there. Okay, the airport, to the double ridges. Okay? If you live in that area, anywhere in that area, you know what I'm talking about here. Because there is no reason for you to be on Wild Hog Road unless you're going where? To Pendleton. Well, what do you mean? You can turn right, yes, but you can turn right down here on Wild Hog Road two or three places. I think there's 3 places you could turn right on Wild Hog Road to get to where? Sandy Springs. Okay? Wild Hog Road is only for one purpose, to go to Pendleton and / Clemson. Okay? That's the only reason for Wild Hog Road. A lot of people say, well, I want to go to Sandy Springs on Wild Hog Road. Very few people turn right here unless they live in this area right here after this road. And the only thing here is Pendleton High School and Bostonville. Okay? So there's not very many houses right in there. Everybody see what I'm saying? I'm using what? Logic. If you get behind somebody on Wild Hog Road, there's a 90% chance that they're going to turn what? Left when they get to that daggum red light. Now, they may turn off the Wild Hog Road, but we're not talking about those people. We're talking about the people that travel all the way from this point to this point. 90% are going to turn left. And that's using logic and a little bit of calculations. So what I'm trying to tell you is, when somebody tells you they can tell the future, they're full of it. Nobody can tell the future. But what is probability? Probability, and you read the rest of the Hubertism definition. Probability is assigning, I don't know how to spell assigning, assigning a number to a prediction based on ... those 3 things. Experience, calculations, which means statistics, what we just did in the last section, and logic. Now, what would be calculated? Well, me taking the last numbers, and I've done this. I did it for to show a class, okay? The last numbers, you can go on to SouthCarolinaLottery.com, which we will in future classes, and you can find the winning lottery numbers for the last year. Plug them into a couple of spreadsheets, and you can try to predict what number is going to come up next. Okay? We actually did that. It didn't work. Okay? If it did, what? There'd be a lot of rich people. Okay? Because there'd be a lot of people hitting the lottery. That's why the lottery is such a good example of statistics and probability. You can do all you can to predict, but you can't predict the future. Now, another example. How many of you have seen Back to the Future movies? Okay? Which movie did, I think it was Back to the Future 2. Yeah, I thought the third one kind of sucked. All right? Back to the Future 2 was probably the best one. Okay? Because he went into the future. And, of course, there was the hoverboards and stuff like that. And he grabbed, what did he grab that was so valuable to him? Sports what? Almanac. Now, if you could do that, that's even better than what? The lottery. Because you could bet for the next, 20 years or 40 years or 50 years? Next 50 years, you could bet on every, of course, you wouldn't bet on every one. You wouldn't win every time. Why? Because somebody would know something. So you'd have to, don't do like Live PD would do. I'm going to go win this lottery, I'm going to win this one, I'm going to win somebody's going to say something and you're going to be investigated and they eventually going to find that daggone book. And then they're going to say, oh, you traveled back in time. Okay? So anyway, the whole point is I'm trying to show you that there is no way to tell the future. I have a friend. Yeah, I got one. All right? And this person says that they can tell the future through dreams. Okay? We're going to leave with that. I said, dream me up to 5 and They wouldn't talk to me for a week after I said that. I said, dream me up the 5 numbers for the lottery and I'll believe you. They didn't talk to me for a week. Okay? You're not going to find too many people that believe in somebody that tells dreams. Now, can I take my life experiences and can I take those and ask you a few questions and say, you better not do that? But that's not telling the future. That's advising. There's a difference. And that's why you need to know the difference. So nobody will take advantage of it. There's a lot of people out there that will take advantage of it. Okay? I was talking to someone yesterday, and they're learning how to dive. You know, dive in the water. Okay? And him and his son are learning how to dive, and he's got a friend that called them and said, will you, I dropped my camera in the lake on the dock, blah, 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 blah. Will you, it's about 15 feet, will you dive down and get it? Because I want the pictures off of it. I want to get the card off of it. Hopefully I can get the pictures off of it. Yes, be glad to. He found it, blah, blah, blah. Got the picture, everything was good. She said, and he charged her for the rental, for the equipment, to rent the equipment, the tanks and stuff, $50. Okay? She called somebody to do that. You know how much they were going to charge her to do it? $550. Okay? Is that taking advantage of somebody? Yeah. That's taking when it only costs $40 to rent. Now, if you buy the equipment, yeah, but come on, $500 for a 15-foot off a dock? I mean, that's taking advantage of somebody. Now, that has nothing to do with predicting the future or probability. But what I'm telling you is people will take advantage of it. And that's why education is so important. So you're not taking advantage of it. So if anybody walks up to you and tells you, I can read your dreams and tell you your future, just walk away. Because they're full of it. Okay? Or if somebody says, I can tell your future, then just ask them one question. What's the lottery numbers? Oh, no, I can't do it. Then get out of my face. All right. But we can take those numbers and we can crunch them. We can take that experience and put it in the back of our head and say to ourselves, that person's going to turn left. And bam, 5 seconds after you say that, they turn left. The next time you do that, ask yourself, are you heading toward a dead end? Where does this road come from? Does this road come from this way? Is there any other way for, and it happens. It does happen. So anyway, that's my spiel on probability. Now, how do we measure probability? We measure probability from 0 to 1. So that means we're dealing with decimals. Now, a lot of people say, well, Hubert, what about percentage? Well, you know how you're not supposed to say ain't in English class? Don't say percent in a statistics class, because some of these statisticians will have a conniption if you say, well, there's 50% probability. They'll have a conniption and say, no, you can't say 50%. You got to say 0.5 probability. Okay? So I'm just warning you. What am I talking about? Well, have you ever go into a psychology class and the teacher is all about statistics and probability? They'll have a conniption if you say 50% probability. They'll have a conniption. So remember that. Try to refer to probability in decimal form. There's a 0.5 probability. There's a 0.63 probability. There's a 0.8 probability. Capiche? There's 2 types of probability. And we'll get into I'm just going to go to the handy dandy PowerPoint for that, because it's all academic and whatnot, and nobody will fuss about not learning what they're supposed to learn. But you know about Wild Hog Road now, don't you? So you feel good about yourself. All right, so that's what we're going to be doing. We're going to be talking about predicting the future. Now, everything I just said is right there. Probability is a measure of likelihood of a random phenomenon or chance behaving occurring. Probability describes long-term proportion with which a certain outcome will occur in situation with short-term uncertainty. Assigning a number to a prediction. based on experience, calculations, and logic. That's the Hubert definition. Here's the academic definition. Okay? Outcomes, that's the prediction. Law of large numbers. This is, we'll get to this, but we're not going to get to it now. I get to it when we talk about classic versus, so we'll get to that later. Sample space, we'll get to that later. I go a certain order. I'm trying to, okay, there's where we see the probability is between 0 and what? 1. Okay? A probability model, that's not what I want. That's not what I want. Impossible. Okay, write this down. If an event is impossible, and I'm going to ask you a question here in just a minute. If an event is impossible, the probability is 0. If an event is certain, it's probability of 1. An unusual event that has a low probability of occurring. All right? If I asked you this, if the probability of blah, blah, blah is 0, does that mean it cannot happen? In no way, shape, or form can it happen. And you say false. All I'm going to say is 2 words. And you can be offended. I don't care. Birth control. Okay? The best example of what I just asked you is birth control. Birth control works, right? But how many times have you heard, oh my gosh, that was an accident? Okay? What happens sometimes on birth control? People get what? Pregnant. Okay? Now, if you could think of another good stick in the brain example, please give it to me. But that's the best example I know of where somebody says, okay, the probability of this event happening is 0. That means it cannot happen. False. That means it's what? Less likely. It's very unlikely. It doesn't mean, I don't like that word impossible because that's kind of giving you the perception that it cannot happen. So I like to take off impossible and mark through it and put very unlikely. Because you might see that type of question on a standardized test. I don't know the exact wording, but it'll basically say, if something is 0 probability, does that mean it cannot happen? And you say, no, false. And you think birth control. Okay? And we'll get into that later. Okay, this is the probability formula. And the frequency of E over the number of trials, that tells you absolutely nothing. How many times something happens over the attempts? How many times something happens over the attempts? Okay, if I flip a coin 10 times, that goes on the bottom 10 times, 10. If it shows up heads, that's how much something happened. It showed up heads 6 times. So 6 over 10. The probability of heads is 6 over 10. Now, whether you're doing Mayberry probability or physical probability, it doesn't matter. You put the number of times something happens over the number of times something can happen. So however you want to write that, that's what probability is. Because if you write that definition out, you probably won't know what it means. Okay? Frequency, remember, is another word for count, head count. How many times something happens over how many times something is tried. Okay? And that's still not what I want to get. I want to get to the 2 types, and evidently they're not going to tell us the 2 types. The 2 types is inferential and descriptive. And I'm trying to get to it. Yep. I don't even have it in here. So we'll have to talk about it, and I'm going to try to just pull it up right quick because where is somebody look in your book right quick, those of you that have a book, and tell me if Anywhere in the book do they talk about descriptive? Well, I'll just pull it up on Google. Be easier. Descriptive
Mention it in chapter 1.
versus, yeah, inferential. I just thought they were, well, no, that's not what I'm, okay. No, that's probably, okay, I'm talking about probability. Okay, forget it. Classical versus theoretical. I call it the Mayberry probability. All right? What is the Mayberry probability? The Mayberry probability, why do I call it the Mayberry probability? Because what is Mayberry? Okay? What is Mayberry on the Andy Griffith Show? What is that a symbol of? Anybody know? What is Mayberry? How many of you have seen the Andy Griffith Show? All right? Describe Mayberry to me in your words. Somebody, give a word to describe it. It's a town, yes, but describe it.
Yeah, I did like a really small town.
It's old. How's a town old? Think about that for a minute. Old. It's dated. Okay, it's dated. Oops, juice is leaking. There's one gas station. What else? Name anything. Anything you can think of about that show, about the town. They got what? Okay, she does not speak very loud. What did she say?
There are 2 gas.
Oh, you're thinking. Okay, I'm supposed to know. I'm sorry. I haven't. It's been. Well, that's one of the reasons I'm single is because I don't understand woman mind reading, and I never have gotten it. So that's one of the reasons I don't. Talk or don't talk. Okay, one of the two. No, I'm just kidding. All right. So name something else. Give me something else about the town.
Isn't it one of those towns that where everybody knows everybody?
Okay. Yeah. Keep going. Go on that line. Keep going. What else about the town?
The police station.
Oh, they all are one.
They're really not professional.
It's why? Why?
There's 2 people working there.
Okay. Why is it not professional? Why is it not like? Why don't they have tanks and guns and why?
Nothing bad happens.
Why? You're getting there. You're getting there. You're almost there. You're warm.
There's not enough people.
There's not enough. There's plenty of people. They never what? They never do anything what?
It's perfect.
Okay. It's what?
It's perfect.
Bingo. And what do we call? You got an A. You got an A for the course. You can leave. All right. What do we call? What do we call a place that is perfect? What do we call a place that is perfect? Utopia. All right. Now, utopia means the perfect and ideal place, right? So, what is the Mayberry probability? The perfect probability, the theoretical probability. So, the Mayberry probability is, let's write some things down. Mayberry probability. It is the perfect. Prefect. It's the perfect. Perfect. It's ideal. It's mathematical. Okay? It's theoretical. Somebody make sure I spell it right. Okay? Theoretical. What is the probability of pulling a king out of a deck of cards? Okay, hand me your deck of cards. Where's your deck of cards? Well, how did you get the probability if there's no deck of cards?
Because you know it based off of experience.
Based off of not experience, but what? The numbers. You know that there's how many numbers in the deck of cards? There's 52 in the deck. How many cards in the deck of cards? There's 52, and how many kings? But you don't have a deck of cards in your hand. That's theoretical. Okay? It's theoretical, so it's Mayberry. Okay? Versus, and we'll do this in the next class, if y'all can handle it. Okay? Guys, the guys, they usually can't handle it, so I have to separate the guys. Okay? But most of the time, if I separate the guys, they can handle it. All right? We're going to deck cards, give everybody a deck of cards and a die. The die is one dice, okay, one dice, single dice. Okay, and you're going to actually do the pulling a, and that's called the physical probability, which is not going to be the same as the perfect probability. All right, stop right there, and we'll continue, because some of y'all are going to start doing the zipper fetish thing. So I'm going to let y'all go. You don't have to run out.
I'm not.
You hate my class that much. Is that it? Y'all get out of here.
Last time we watched the Big Bang.
What class is that? Slender Man's?
Psychology.
If I showed a movie in here, right after class, I get a phone call. He showed a movie in there. He's supposed to be talking about math.
This one.
Show us a movie about math.
How do
There
you,
is none.
How do you know?
That way,
What,
I don't know what.
like, how do you know which category it belongs to?
Okay, first of all, that one's negative correlation. This one is no correlation, and this one is negative correlation. Both of them are strong. Now, this one says match linear correlation to the scatter diagram, blah, blah, blah. All right, where is a negative 0.49? Well, a negative 0.49 is kind of shallow. All right, so I would probably go with this one because it's shallow. It's not.
But like, how do you know that it's shallow?
Just by looking at it. You usually look at the far left corner and the bottom right corner and see that it's about a 45-degree angle, but it's got a lot of dispersion. It's got a lot of spreading out. Hold on just a second. I don't want to record this. That's why I'm got to